Thank you, Gael, and hello, everyone. I'm going to share my screen. Okay. So following the presentations given by my colleagues before, I'll provide you some an overview, a general overview of the exercises that have been proposed for this WEkEO for forest monitoring training session. So I will introduce briefly QGIS and WEkEO products that have been used for developing the exercises, and I'll go then giving a short overview of the proposed exercises with some references and conclusions at the end. So the scope of this training session is to provide basically some examples on how we can use geospatial tools like a geographical information system for manipulating, analyzing, and computing some relevant metrics starting from the Copernicus products. And particularly, this training had the main focus on visualizing the products related on land use change and forest monitoring, accessing basically the variables that are supporting in this sense, and providing a very short overview about the potentiality of QGIS in analyzing this kind of geospatial data. But before starting, I would like to recommend you to go in the WEkEO for forest monitoring page, where you have a dedicated section about QGIS with information about the software, how to download it, how to download also some plugins that have been used along the training session, together with a video and a document that summarizes and somehow also explain the main steps for developing the exercises. And stay tuned, because in the incoming days, an updated version of this document will be also available for you all, with more additional details on the ones already provided in the document. Of course, it is also needed to mention the fact that we are using QGIS, that is an open source and free software developed by a wide community. And in this specific training session, I've been used the last version of QGIS, the 3.38. So QGIS offers two possibilities for installing it in standalone mode. So basically downloading the executable from the web page of QGIS, where you have also the access to the long-term release, and also an advanced installation through OSGeo 4W that allows you to simultaneously maintain different versions of QGIS in your laptop. But now let's dive a bit more in our training session. And in particular, this slide summarizes the main upstream data that have been accessed and used throughout this training session. Indeed, Alexander already showed you how to access them from WEkEO. So I basically used 4 products: the core inland cover that is made available by the Copernicus Land Monitoring Service, the land surface temperature, as well provided by the Copernicus Land Monitoring Service, and the essential climate variables. Particularly, have been accessed the 2-meter temperature, relative humidity, and total precipitation. They are provided by the Copernicus Climate Change Service, and the normalized difference vegetation index provided by the Copernicus Land Monitoring Service. All these variables are, of course, part of the huge catalog, as you have seen, available in WEkEO, particularly for supporting this kind of analysis and studies about forest monitoring and understanding of the forest ecosystem capacities along the time. So the first exercise that was proposed is related on the core inland cover. Core inland cover data is provided by WEkEO in GeoPackage format. So I'll keep somehow a link also with the previous questions about the supported formats by QGIS. And this is done basically by adding the GeoPackage file through QGIS after selecting the data manager. Of course, here you have, as a product, the Corinne cover is characterized by many information inside once you download, including metadata that are fundamental for developing the exercises. Indeed, as shown in the technical document, after importing the GeoPackage file into your QGIS environment, you can customize the legend by accessing the properties section in the active layer once selected, and through the legend file that is available in the Corinne cover product, you can basically fulfill the last step of the workflow that embeds the codes of the classes of your Corinne cover, and then you can display it as I show you in the video and in the technical document in your QGIS environment. Of course, we can use QGIS for selecting an area of interest and make some subset, or simply querying the map point by point. And this is what I've explained in the tutorial. So basically, in the area, I selected an area in Spain, the National Park of Cabañeros, that is well monitored, especially because it's one of the most peculiar and critical area because of wildfires. And this kind of tools can be extremely supportive in this sense. Of course, you can use some basic statistics for computing the metrics, as I've done here, by showing the characteristics, the spatial characteristics of the selected area, and particularly for the area covered by the class 3 that is related on forests and vegetation. The second exercise is instead working on the land sea temperature that is provided as netcdf file. In this case, we can access and import the file through the netcdf plugin provided by the Copernicus Marine Service, as I've shown in this slide. And after ingesting it in your QGIS environment, you can display it and manipulate the legend and the symbology as you prefer to improve the user experience for analyzing this kind of product. And of course, QGIS provides also some functionality for computing some arithmetic operations. The example here shows that the land sea temperature is provided in Kelvin. So through the raster calculator, we can convert in Celsius and display it in the map, as I've done here. So again, we can subset the map in a specific region of interest, as I've done in the same bounding box that I was selecting before. And here you have basically the land sea temperature that is focused on the area of the National Park of the Cabañeros. And this is done by basically working with this kind of file that is a raster and performing an extraction by using the mask layer as previously defined. So the red box previously drawn in your map. The third exercise instead focuses on the essential climate variables that are also relevant when you want to monitor the characteristics of your specific region. They are provided by WEkEO in GRIB file, but also, as Alexander said, you can specify how you want to download this kind of files, and in experimental phase, there is also the possibility to download in netcdf. I use the GRIB file to have the opportunity to show that the importing of this file through QGIS is extremely straightforward, because you can add basically it as a layer, as a raster layer. And as soon as you have done this for the 3 climatological fields that I have been accessed, you can display them, in the layer board. Of course, another important aspect that any geospatial analyst would like to do is to extract the information on some specific region. And in QGIS, by typing the keyword world in the panel below, where there are the coordinates of your map, you can display basically the world map layers that I'm showing here in this chart. And after that, you can simply display the 3 fields, as I've done in the exercises, and customize the palette of course, to improve the visualization of these physical fields. Then, as I mentioned before, the world map is extremely useful because we can select any of the area or the region or the country that we are interested to analyze. And by following the workflow that is here represented, so clicking, selecting, and saving what you have selected in a specific layer, you can then obtain, for instance, in this case for Greece, the specific layer where you can compute the metrics related or the average values for the essential climate variables that you have been downloaded. And this is done basically by computing statistics through the processing toolbox zonal statistics function that is available in QGIS. And once done, and of course following the steps that are also described in the technical document, you can finally achieve this kind of output where you can compute the minimum, the maximum, and the mean value, for instance, of the total precipitation, relative humidity, and 2-meter temperature in the Greek country. The last exercise that has been proposed is related on the NDVI, that is important variable, as you know, for characterizing the vegetation coverage in a specific region. And this is provided by WEkEO as an HCDF file. So again, this can be easily imported by using the Copernicus NetCDF plugin. And as when you do this, of course, every time you import a new file, this is displayed in the QGIS with the default symbology. So then you can act in your in the properties layer of your active layer and set the ranges that here are representative for the NDVI, particularly when the values are -1 is referring to area with water bodies and so on, or snow area, when it is 0 with bare ground, and when it is 1, the region means that is with dense vegetation. And this is an example here of the resulting field as you can display in QGIS. Of course, I mean, when we want to monitor specific events or specific regions, we would like to cross-check and cross-link all the layers that we have right now imported. And this is done basically by exploiting some processing toolboxes that are provided by QGIS. In this way, for instance, choosing sample raster values, so points where I'm interested to extract at once the information from the essential climate variable and the NDVI in these 3 regions, and using the toolbox and particularly the sample raster values, I was able to run in batch process, so in one shoot, all the files and extracting the relevant information, as it is shown at the end when you run, and these steps are described also in the document. You have basically the tables that contains the information of the essential climate variable and the NDVI in the points that have been selected, and by merging them in a single layer, you can display a table that further can be exported and manipulated in other, for instance, in Python or in any other language, if you would like to, or simply interface with your downstream application. So conclusions, very general, of course, QGIS offers many capacities for analyzing Copernicus products and supports different file format. You have seen that WEkEO offer not only tabular format files, as Alexander was saying, and CDF, but also GRIB and GeoPackage. These are pretty easily to import in QGIS. We can perform some mathematics in the rasters, or more in general, in the layers that we are able to ingest in our QGIS by using raster calculator or geoprocessing tools. And this is very useful when you want to calculate metrics or quantify some specific variables in the region of interest. And with zonal statistics, it is also possible to compute average quantities, for instance, for the essential climate variables for monitoring purposes, not only as I briefly show here to you, in one specific layer, but you can also try to download a short time series and use the zonal statistics tool for computing the relevant statistics also over time, and then continue your analysis, your spatial analysis with QGIS. So thank you very much for your attention.
Thank you very much, Stefania, for your presentation. So we will move on to the Q&A session. So for now, we have just a few questions for you. So the first one, so we had it at the beginning of the session. Maybe you can have a more detailed answer. Is the data processed in this platform can be used in others such as ArcQGIS and ERDAS Imagine?
I personally don't know ERDAS Imagine what if it is a software or specific product, so I apologize for this. I will detail later on, but surely for the first part of the question, of course, the training, the examples are proposed for QGIS, but they are extremely applicable also for other GIS environments like ArcGIS. So the answer is yes, you can process. Of course, what is going to change is, as expected, the way of the functions are available, but in principle, the logic and the steps that you need to follow for manipulating this data is pretty equivalent.
Okay, thanks. Thank you. So it's also almost the same question that we have here about Alfred being an ArcGIS Pro users. So is new in the QGIS software. Those all data from QGIS can be used in ArcGIS Pro and vice versa. ArcGIS
Yes.
Pro. Yeah, it's also working for the Pro here. Okay.
Yeah,
okay,
yeah, absolutely. Of course, I mean, the principle of any geographical information system is to work with raster and vector layers. So in principle, the commands that are proposed here for QGIS can be ported, could be nice to be reproduced in your ArcGIS environment.
Okay. So this question about how to use QGIS for forest mapping. So kind of what you did in the tutorial.
Yeah, I mean, at least it was a first attempt, or just to maybe a bit concise, but of course, this training is not pretending to give the full overview of the capacity of QGIS, but also of the specific topic that is forest monitoring that is quite important. So my advice is to of course, we go in the WEkEO catalog and search for the variables that are related on any kind of spatial understanding of the distribution of vegetation in your area. I tried to do this basically in this tutorial, keeping the information that to me might be relevant for doing a first assessment of forest mapping and land use, like the core inland cover that contains basically all the information related on the forest mapping with the class 3, as I shown, but of course you can expand and add also other layers, as Alvaro was showing before, about air quality. I mean, the WEkEO is really rich of data, and it depends, of course, on the kind of analysis that you would like to perform.
Yeah, exactly, yes. This question, why do we need to use the NetCDF data since the area another common raster data? Could you explain the advantages using NetCDF format data?
Well, of course, there are also, the GeoTIFF is a georeferenced information. It depends, I mean, there are some communities that are working intensively in developing, of course, application based on ingestion of raster data like GeoTIFF, but as well the community is expanding and taking benefit of the standardization of the NetCDF format that contains also information inside the metadata about the data source, the data origin, the data processing. So it's a matter of opportunities in the kind of analysis that you are performing. Of course, for some specific application, the raster data, the GeoTIFF are quite straightforward, easy to manipulate and to ingest. For other kind of analysis, like the for instance, keeping track of the source of the data, the NetCDF can be supportive as well. So, I mean, there are advantages in using both. It's not, indeed, WEkEO is providing for some of them, for some of the products, different format, because it is the community requesting for that.
Yes, exactly. So, yeah. This one question, so about how to access the data. So I couldn't get the data as I missed a related session on the first day. How do we get the data? I manage COWIN, but now the climatology. So all of the data, you access them by the WEkEO viewer, if I'm not mistaken. So it was shown in one of the previous presentation of this morning. You can have access to the replay in about 1 week, but maybe you want to say a few words also to recap everything.
I mean, just to complete your nice explanation, Gael, in the document I have also reported the dataset name. So for that you can check which is the and put in the WEkEO search bar the dataset name that is also available in the document, and see for the land sea temperature what I have been downloaded. Otherwise, we can support you with more specific information if you still have problems in finding this dataset.
Yeah, the full tutorial is well explained for the downloading. Okay, so this one about a specific plugin. Can the NetCDF plugin be used in the QGIS 3.38 standalone version, or just the OCH network installation? Sorry for the pronunciation.
Yes, the answer is yes, in the sense that the two ways that you are downloading and installing QGIS standalone or through the network installation gives to you at the end the QGIS software. Then in QGIS software, you can add any kind of plugin through the plugin manager, as well as the NetCDF. So you can do in both cases. At the end, the plugin is going to support and serve the QGIS software.
Okay. Okay, thanks a lot for the explanation. Oh, sorry. Okay, so I think I have an internet issue, but we will move to the question just under it. I have successfully installed the zip plugin for QGIS that you provided in the course to load NetCDF file. I cannot find it in the toolbar. How to make it appear?
If I'm not wrong, in the toolbar, when you are in the top panel of the QGIS, by doing right click, you have several options, and you might select the one related on the properties of the toolbar, something like this, and you can find. But I'll search better to give you an answer more specific. There is a way. It's just sometimes it, also depends on the version of QGIS from one to another, since they are doing many an important refurbishment of the code. It might be that simply it's straightforward in one version and not in another. But I'll check in the 3.38 version and I'll let you know. Okay, thanks. So I will put the question aside for more detail in the post-event report. Okay. The next question, again from Alfred. This platform is very useful since I'm working in GIS world of work. I love WEkEO. Okay, great. Good.
Is the base map of this QGIS updated? How often does the base map update?
In the tutorial, I show you basically a way of importing the base map that is the OpenStreetMap, but you have also the quick mapping plugin that you can choose, and I invite you also to check other training session where I explained that. And basically, it's a plugin that you can, of course, install in your QGIS, and then to perform a search in the network, in internet, with some other providers of base map like Google, NASA, and so on. And in this way, you will always access the most updated version of base map. So there is a plugin, quick map service, something I don't remember now the exact name, but again, I can be more specific if Gael share with me this. I can share with Gael the answer, and she will forward to you. But it's possible with the plugin, but surely.
Yeah, I will also put the question on the side to not forget about it for the report. We have like three questions, so I would put this one on top, but 3 questions about the QGIS version and the plugin name. So on the full tutorial, on the documentation, if I'm not mistaken, you run several tests with different versions of the QGIS.
Yes, surely with the long-term release, that is 3.34, and the last one, the 3.38. Every time we try to test the new version, but of course the compatibility with the plugin, particularly the Siemens NetCDF, is tested every time, and it works. So the answer is yes, it can work also with other version of QGIS. Now, which is the limit of this on the way the QGIS can import this plugin in terms of version, I really don't know. But surely for the last year of releases, yes, it has been tested and the plugin works.
Yeah. Okay. Oh, okay. Sorry. Okay. Yeah. So we invite you to have a look at the documentation Stefania made for the training. Yeah. And one last question before we move on. So it's a more general and open question. Do you have any say on how to use QGIS for climate change monitoring?
Well, indeed, this is very general and very nice question, because gives the opportunity to say that these kind of tools, together with Jupyter notebooks and other kind of languages, support, of course, the studies and the monitoring on climate change. So, of course, what you could do, as I was mentioning before, is to download more data from WEkEO for a longer period and exploit the capacity of QGIS for subsetting in a region of interest, where, for instance, you would like to analyze the impact of the land change use and because of droughts, extreme events like droughts that can occur in some specific region and that can have impact in flooding or in other events that consequently can occur. So QGIS helps, of course, in performing geospatial analysis, in realizing maps, in cross-linking layers that can be queried in a very automatic way, and can support also activities related on monitoring by selecting area or points or region or countries or any, but even transects, sections, I mean lines basically that you can draw in your as I show in the video, if I'm not wrong, and you can monitor, because QGIS gives to you the possibility to extract all this information and then compute indicators or the right quantities that might support monitoring, I mean, on understanding of the impact on climate change in specific regions through events that might occur.
Okay, well, very nice answer. So thank you very